I'm Rasmita Raval from the University of Liverpool. Mark has set out the scene for NBIC and what we have been trying to achieve in the last a few years, and as we go towards our next phase. So 4 intervention themes were defined right at the beginning of this IKC, and they were defined by industry. These were the 4 areas they really felt needed to be addressed by a new IKC. And Mark has indicated what they were. Each of those themes is led by one of our core universities, so Liverpool, Southampton, Nottingham, and Edinburgh. And we have co-directors at each of those universities. So we have Indetect, Southampton, Jeremy Webb, we put your hand up so people know who you are. Manage, we have Miguel Camara here from Nottingham. And engineer, I know online we have Kate McPhee, who I'm sure is virtually putting her hand up as well. So these 4 universities coming together to try and provide some leadership or thought leadership in this area. So this is the 4th workshop. We've done them for the other 3. This is the last of our workshops on prevent. So I just wanted to do some scene setting here so that we catalyze the conversation for the rest of the day that is so important. And as I set the scene then, we go back to an IKC, Innovation and Knowledge Center. It was both innovation and knowledge that was required in this area of biofilms. So what would prevent look like? What would be a remit or a strategy? So from a research point of view, then we would say prevention of early stage microbial adhesion and colonization at surfaces or interfaces. That is where the focus needs to be. What happens? What happens when single cells come in onto an interface? How do they behave? And that very much drives a lot of the research questions. If you talk to industry, they have quite a different view on this. They just want to curtail, in many cases, that early stage biofilm so that performance is retained. So you're not talking about no adhesion, but just some kind of happy coexistence, as it were, that allows performance to continue for long periods of time. And each of these then require a different strategy, a different knowledge base, a different innovation space. So early stage is a standard biofilm model looking at this early stages, early stage biofilm. And you realize that that boundary is not so defined, it is diffuse and it's elastic, depending on the technology you're looking at. So it can go towards manage in some ways, or it can even be important in the final stage as you go back into prevent. So what do we need? What do we need in this area, both from a world perspective, but here today from the UK perspective? And at the basis of all of this, and the reason why there was an IKC was there was a knowledge base that was required. And this was understanding the technology, the man-made technology, and the biological interface. So the best that we could do in terms of our knowledge, and a race and an arms race versus billions of years of evolution from biology. And it is that interface that really becomes so critical in prevent, because that is when both of those 2 aspects play a pivotal role and an almost equal role. And so this then now becomes a knowledge base that needs to be explored, from which we create a toolbox to allow us to address this area. And I'll just come back into it into a second in my next slide. But the sheer interdisciplinarity that's required here is one of the driving force for NBIC. Knowledge should be unconstrained. We should seek knowledge and information wherever it's interesting. But sooner or later, it is important for many of us who are in the academic sphere to move towards innovation and translation. So should you go down that route, and that's an important part of what the IKC does, then you have to think about how do you test your technology? does it work? How does it work? And here then, some really important aspects come out, which are so important for industry. What is a biofilm model you would use in this case, in this early stage? What would this bioassays look like? And I'll come to that in a second as well. And then finally, you have something you tested in the lab. You need to translate it to a real working environment out in the field. And that then requires you to work within even further constraints, regulatory frameworks being one of them, the most important here. Not going to sell a product unless it is within the regulatory framework. And this really focuses industrial thinking, but it now needs to focus the academic thinking as well. And you can have all of those things, but unless your technology is robust, i.e. it lasts long enough, it's upscalable, it's realizable, it doesn't go beyond an interesting proof of concept. And so what has been really nice as we started our proof of concepts that Mark has talked about, that about 40, almost half of our proof of concept projects are related to this theme. I.e. this theme that has all these different aspects has created a lot of energy in our IKC community across the country. And we have then created partnerships. So researchers coming in with partnerships across a whole range of industries, and some of them are put down here. You can see global multinationals, you can see SMEs, and you can see micro companies as well. So this space has been opened out to lots of people, and it's been fantastic to see that energy that's come from all of you. So let's now just take knowledge testing and translation, and these are some of the things that you may want to explore. And knowledge, understanding the technology-biology interface, and really the sheer scale of interdisciplinarity that needs to be harnessed here is staggering. And this is why the academic base is so important, because I've just put in some of the things that are required here. You're dealing with an interface, a surface. So you need to know your surface science, which is different from your material science, which you also need to know. You need to know your engineering, where you might want to upscale to larger volumes. And then you need to know what is happening there. So not only are you levering across these different areas, you're trying to do it at often the single cell level, at the single atom or a nanoscale level, in order to have that control, so your knowledge is tractable. And so that you have an idea of how you might use knowledge-based structures to drive your innovations. And that is just bringing in a bit of physical sciences. You need to model all of these things. So we need our modelers to look at how can you predict what's happening? How do you do data mining? And you have to tie in that physical sciences with biological and life sciences. What do your interventions do to the living system? What are the interfacial interactions? What do bacteria or microbes do to the surface? What does the surface do to the microbe? That conversation is still elusive. And this is a great challenge. It's actually an exciting challenge, both for research and for innovation. And then you need to understand the mechanisms and mode of action. And I have learned so much from my fellow co-directors from microbiology to see the way a biological system responds, and the subtlety and the variety of its response, and how do we make our technology come and step up to that level of working. And so then you have function and activity, our sciences of omics and bioinformatics coming into what is a very small, probably just a few microbial colonizations at a surface. So you're driving not only length scales, you're driving sensitivities down, so you can see these things at the level they need to be seen. And then always complexity. So depth of understanding tied in with complexity, and that becomes a really important part of what we're trying to capture. So this is our knowledge base. It's huge, it's deep, But this is where the university sector comes in. And this is why in NBIC, we are so proud that so many of our institutions have joined together in this quest for knowledge that's coherent and combined. Then you come up with a nice idea in the lab and you want to see if it works. And then suddenly come to the harsh world of biofilm models. What models do you use at early stage biofilms? This is a big topic of conversation, and I know for mature biofilms, there's some consensus being created on what might be considered a model. I'm not sure we quite have that at the early stages, and that is a discussion that would be most interesting to have. You know, how do you test it? What is a bioassay you use? So we actually have just a paper that's just been submitted looking at a particular ISO test that's used for surface bioassays. So we reviewed a literature, about 60 peer-reviewed papers. Of those, only 17 gave any kind of detail. They just mentioned the ISO test, but never any detail of what was done within that test. And then we just looked at each of the areas and see, so who complied with the ISO test? Who definitely did not comply, and who doesn't even mention it. So green on the side here, you see some of the things, so some of the variables that are involved: the bacterial strain, the suspension media, the cell count, incubation conditions, inoculum volume, plating media. Look how small the green bars are on those areas. And look how big the red are, where they do not follow or we don't know. And the interesting thing is that if you take a standard material and just allow for the variations that were seen in the literature, we would identify that technology as being not very good to being very good. And here is the problem: what is good? And that requires standards. And so there's a big drive in NBIC to look at standards, and we'd like to hear your views on what could be done here. Then we come to translation. So you have something that works. You need to make it affordable. And here now, it's just two examples of translation in PREVENT. I have drawn this from our university, but I know there are fantastic successes elsewhere. So the top one is actually using smart delivery systems, which are really the forte of scientists in labs, using them for marine antifouling. And you go from designing these capsules, these trigger systems, all the way out to testing in the Red Sea, which is really challenging in terms of the environment, and find that this knowledge base translation actually does work pretty well. And some of these are now being put out onto ships and being trialed further. So here is an example, and to give you some kind of faith that fundamental research done well and translated does lead to innovation that is interesting. The second example on the bottom half of your screen is something that my group has been working with a local company, Gencar. So we had a proof of concept here that was kindly funded by NBIC. We translated that to a completely different area via 2 Innovate UK grants. And here we are now creating self-sanitizing films. So we started with nanoscale design and control. From our lab to the actual production lab. It's gone on to field trials, which are actually coming back pretty successful. Now looking at high volume manufacturing at prices that would allow people to use this. So really very fundamental science to high volume manufacturing, through the connectivity that something like NBIC, which brings the research and the innovation ecosystems together. So finally, I just finished with some of the proof of concepts that we have in PREVENT. I won't go through any of these in detail, but you can see the different universities that we have here and the companies that are have come together. And I think we're very proud, I would say, our proof of concepts. Mark mentioned the number. Mark, what's the final number we funded?
81.
81. What is 81, right? It was bringing in something like £7 million of translational funding injection into the UK to carry out innovation. Many of these then translating across. That's a fantastic effort by all of you coming together with fantastic ideas. And so a whole range of proof of concepts that have been funded, and many of them now going forward. Not every proof of concept is easy to take forward, but done in the right way, we can show to the taxpayer that the freedom with which we enjoy our science does lead to products and services and wealth for the country. So finally, I take a slide. Miguel, thank you for this slide. The sectors. What comes across here is not just the range of universities, the range of companies, it's the range of sectors as well. And across all these sectors, there is a real opportunity here for Prevent to come up with answers that are new, exciting, and fulfill the constraints of innovation. So that's all I have to say. I hope you have a wonderful day here, and we hear wonderful ideas that we can take forward as we roll forward. So thank you very much.